Hi everyone, Grandad here again. What am I up to today? Well, today I'm going to do a little bit of chemistry with you. And what I'm going to do is try and produce some ammonium chloride. Now, ammonium chloride is quite a useful chemical, and I'll probably use it in other videos as time goes on. But my bottle's getting a bit empty, so I thought I'd make some more. Now, its actual chemical symbol is NH4Cl. And I keep it in this little bottle. Now, the two chemicals you need for making this ammonium chloride are a thing which we call in England spirits of salts. Now, this is bought from a local hardware shop, and we call it spirits of salts, but in America I think they call it muriatic acid. But its actual name is hydrochloric acid. Now, it's quite a nasty acid, and it fumes a lot. Now, that'll become apparent in a minute when I open it, and they're not very nice fumes, so you don't want to breathe them in. So I'm doing this outside to get rid of the fumes and not to breathe them in, because that's not very nice. The other chemical you need is this one, which is household ammonia, and this again can be bought from any hardware shop, and it's for washing. Now, you want the type that doesn't have any additives. This hasn't got any additives, it's just the pure household ammonia with no flavourings or lemons or any sort of colouring in it, so it's a clear one. Now, both these chemicals are actual gases dissolved in liquid, which is interesting. Now, in order to make our ammonium chloride, we're going to have to, for safety purposes, put on some rubber gloves. And I've already got my clothing protected with this apron I'm wearing. And I'm putting on some rubber gloves, and I'm also going to wear some safety glasses. Now, I wear glasses, so I've got a little protection anyway, but for the purpose of this I'm showing you that you should always wear safety glasses, because when you're dealing with any sort of chemicals or scientific sort of reactions, you never know quite what's going to happen. Sometimes they go okay, exactly according to plan, and other times you run into trouble. So, in the interest of not running into any trouble, I'm going to try and show you how this is done. Now then, we get our spirits of salts, and I'm going to pour, if there's enough left in my bottle, which is getting rather empty, I'm going to pour about, see how much we've got. I don't think there's a great deal left in here. There's 50 mils. In there, and I'm going to pour, hopefully, the same amount in here. Now, I can already smell the fumes coming off that spirits of salts or hydrochloric acid. And I'm going to open my ammonia now and pour what I hope will be about 50 ml in here. Let's hope that's about enough. Now, you'll notice, or I hope you can notice, when I bring these two beakers together, there's fumes coming off both of them. But in the air, surrounding the lips of these two bottles, there is white smoke being produced. I hope you can see that. There's white smoke being produced. Now, that's just with the fumes coming off the two chemicals. And they don't smell very nice, I can tell you. Now, when you actually, before I put these two chemicals together, I'll put this thermometer in there, just to check really what the temperature is. And it's quite warm out today, but I'm hoping that that particular one's reading about 65, 70, about 70 I think, on this little Fahrenheit thermometer, I think it is. And likewise, now you notice as I poke that in, we got a little flurry of smoke there. and this one's about the same. But when I add these two chemicals together, not only do we get this fuming, which you can see, but when I add them together we'll get even more. So I'll do that very slowly now. And there we get a terrific cloud of smoke being produced. Luckily it's blown away from me and not to me. So now we've got our two chemicals mixed together. Now if I just roll them round a little bit, get them good and mixed, I can check on the temperature. Now already the temperature, adding those two chemicals together, the thermometer, and you won't be able to see it probably, but I'll tell you what it says. It's over 120. So it's crept up considerably. So that is a chemical reaction which has caused heat. So it's a thermal reaction, and it shot up over 120 from just round about 60. I'll just bring that over, hope you can see that. But that's over 120 degrees. Now I got the rubber gloves on, but I can feel the heat through there. And it's quite warm. Now I'm going to leave that for a few moments to just cook and for those chemicals to react with each other. So that's an interesting chemical reaction. Now what you do with that is you have to reduce the quantity, because although we've now produced our ammonium chloride in that liquid, we can't get at it. It's still in liquid form. So what we've got to do is reduce down and concentrate that liquid as much as we can. And the way we do that is with a stove. Now over here I've got a stove with a pot on it, and it's an induction stove, so it gets pretty hot pretty quick, and you have to use a pot, a metal pot on top, otherwise it won't work. But I've actually got in here another beaker of ammonium chloride which I made earlier. I made another video of this prior to this one and it went wrong. I got it wiped somehow, so I wasn't able to do it, so I've had to repeat the test. But in fact it's helped us a little bit, because this has been boiling on there for perhaps 20 minutes or half an hour, and already in this liquid I can see that there are some, sort of gone a bit greenish, but if you can see, I don't know whether you can see it, but I hope you can, there are some crystals starting to form. Now that has happened because I boiled down the liquid and reduced the quantity and boiled off some of the water from that liquid in order to get the crystals to what they call precipitate out. In other words, they've come out of solution and formed little crystals. Now there's quite a lot in there, and that's just by boiling it down a little bit until those crystals start to form. Now because I've got another bit here, I'm going to add it to that and carry on with that project. Now you'll see the temperature is now dropped down, it's well below, it's gone now below 120. So the chemical reaction there is complete, and it's actually cooling down. Now I'll add this now to my other quantity of ammonium chloride which I've made, and I'll switch on the boiling mechanism here, switch on the stove again and boil it down a little bit more till I see those crystals, because when you look in there as it's boiling down, you reduce it by about a third, 2/3. You don't want to boil it dry, because that might decompose the ammonium chloride and make it not so good. But once you get it down to a point where you can see crystals forming on the surface of the liquid, it'll form a sort of a little crust coming, like a skin. And that's when you've heated it enough and reduced it down and concentrated enough. Now once you've done that, the liquid still will be fairly clear. I mean, it's gone completely clear now. Those crystals that were there have disappeared. So that shows you how easy it is to dissolve the crystals. So I need to boil that down again to reduce the liquid content, so that the crystals come out of solution, or start to come out of solution. As soon as I see that, I can take it off and put it in the fridge. Once it's cooled a little bit, don't put it in the fridge too quickly. I can put it in the fridge, and when you put it in the fridge, it will bring all the crystals out of solution. Now this solution has gone pretty clear from being in the fridge, and there's a white substance floating around in the liquid. That means all the crystals, all the ammonium chloride, has come out of solution and is now floating around. Now the only way to get that out of there is to filter it. Now you can wash it, but if you do wash it, make sure you use ice cold water, because if you don't, you'll dissolve your crystals again and they'll go back into solution. So the only way you can use this is to keep it very cold, so it's best kept in the fridge, and even though it's been out of the fridge a little while, this needs to go back in to be cooled right back down again. And once this is boiled down sufficiently, I'll add that to it and precipitate out all my ammonium chloride. Now once you've got the ammonium chloride out, you need to filter it, and once you've filtered it, you will end up with a white, snow-like, fluffy white crystals. Looks like sugar or snow, and that is the ammonium chloride. Now once you've got it out of there, you can quite safely, when it's dried off, you can quite easily put it into your little jar or wherever you're going to keep it in and store it for when you need it. It's quite a solid lump. So that's how you make ammonium chloride. I'll just have a quick recap. You start off with your household ammonia. It's only cost me $1.75. Your spirituous salts, or hydrochloric acid or muriatic acid. Mix about 50 mils of each together, very quietly. In a Pyrex dish, you want to make sure that the jars you use are Pyrex or some heat resistant materials that aren't going to crack when you heat them up, because they heat up quite quickly. So I wouldn't recommend doing this in the jam jar, because it might actually break. But they must be proper chemical resistant glass, especially made for the job. And it shows those three interesting chemical reactions: the fuming, which produces the chloride gas, which is an interesting reaction, because both these chemicals are gases, and they want to be gases, hydrogen and ammonia, and so they make this ammonium chloride, which was floating around in the gas. And then when you mix them together, you get a big cloud of ammonia gas, but they mix up in the liquid form, which you can then heat up to reduce and get out of solution by cooling. So it shows the interesting ways in which chemistry works, and I find that fascinating. So I'll go on boiling my ammonium chloride back down again now, and until I see you again when we do another video on chemistry, I'll say goodbye now. But remember, keep safe, wear all your equipment, and have a happy time. Bye bye now.